Hi, everybody. Today's notes, you're going to take what you learned about scientific notation, both positive and negative exponents, and we're going to compare and order those numbers in scientific notation. So when comparing, you're going to compare the exponents. The largest exponent will be the larger value. The smallest exponent will be the smaller value. So when you're comparing these two examples right here, 6 and 2/10 times 10 to the positive fourth power, and 5 and 23 hundredths times 10 to the positive seventh power, the larger exponent, and I put an arrow there, is the positive 7. Therefore, 6 and 2/10 times 10 to the fourth power is less than 5 and 23 hundredths times 10 to the seventh power. So what happens when you have negative exponents? 5 and 15 hundredths times 10 to the negative fourth power, and we're going to compare that to 6 and 35 hundredths times 10 to the negative fifth power. What I'd like to do is make a number line, and I made a quick but sloppy number line over here, and 0 is in the middle or at the very top in this case, and we're going to look at -4 and -5. Now I like to pretend that I'm 0 and I'm looking down. All right. And when you're looking down, if you're standing up high somewhere and you're looking down, what's furthest away from you is the smaller value or the smallest object. So in this case, our largest value, -4, is greater than -5. So over here, I just put an arrow showing you that -4 is greater. Therefore, 5 and 15 hundredths times 10 to the negative fourth power is greater than 6 and 35 hundredths times 10 to the negative fifth power, because -5 is less than or further away from -4. So what happens if the exponents are the same? So what happens if we have an exponent that in this case is both 17? What do we do then? Well, then we look at the coefficients. So again, if the exponents are the same, we're going to compare the coefficients. So looking at 3 and 28 hundredths times 10 to the positive 17th power and 4 and 25 hundredths times 10 to the 17th power, well, since both 10 and 7 to the 17th power is the same, we're going to look at the coefficients 3 and 28 hundredths and 4 and 25 hundredths. Well, what's the larger value? 4 and 25 hundredths. Therefore, 3 and 28 hundredths times 10 to the 17th power is less than 4 and 25 hundredths times 10 to the 17th power. So let's take 4 values and let's order them, in this case, from least to greatest. So pause the video for a minute and write down these 4 values. What I'm looking at here, first of all, is my exponents, okay? So I see that I have some negative exponents. So I stopped and I made a number line. Here's my 0, or I can pretend that's me, and I'm looking down at -4 and -7. You can see that -7 is furthest away or smaller than -4. So since we're ordering these values from least to greatest, I have to look at my smallest value first. Well, we have a little bit of a road bump here because we have 2 values that both have -7. So what do we do then? Well, we look at their coefficients. And since we're looking for the smallest value first, we can compare 2 and 81 hundredths and 2 and 72 hundredths, and we can see that 2 and 72 hundredths is the smallest value. So we're going to put 2 and 72 hundredths as our smallest value first. And since 2 and 72 hundredths times 10 to the negative 7 power is the smallest, then we knew, because we looked at the coefficients, that 2 and 81 hundredths times 10 to the negative 7th power was next from least to greatest. Then, obviously, was our 9 and 45 hundredths times 10 to the negative 4th power. And then the only positive that we had, which is above the 0, would be 2 and 100ths times 10 to the positive 3rd power. Now you're going to do some practice, and if you still need extra help, there will be another slide to help you.